G'day and welcome to this the third video now actually on the integration, and this one will be looking at integration of exponential functions. And again, I need to stress that it's the natural exponential, so e to the power of. This won't work for 2 to the power of or any other to the power of. It only works for e. Just one of those unique things. You can ask me more about that later if you would like to know more. So if I'm going to use differentiation to kind of prove integration. So when I diff e to the power of x, e to the power of kx, I get k multiplied by e to the power of kx. So the diff of the top is multiplied by the original function. So if I anti-diff this function, I'm going to get back to my original f of x plus c. So if I anti-diff k e to the kx dx, I should get e to the power of kx. I guess the way that I can find out what the antidiff of just e to the kx is, which is essentially what I want to know in all of this, I can take the k out the front because k is just a constant, just a some number, and then I get k multiplied by e to the kx dx equals e to the kx. And then I can just divide both sides by k because it's just a constant. And I get 1 on k e to the kx and then plus c. The reason I've got this plus c in black is because I didn't need to put this plus c up here. In fact, if I did, I'd have a plus c here, and then I would have to divide the c by k as well, so it would actually end up being c on k. The reason I don't need to do that is because it doesn't really matter to me what c is, it's just representing a constant. So if I wanted to put this c here, I couldn't then go and just put a c there. I'd need to use a different letter like a d or an f or something, but it's the same idea. It's just this plus c just represents a constant. So I'm going to say just leave it until right at the end. Don't forget it, you have to have it in there, but just leave it right to the end and then you can work it out. In fact, in some questions you can actually work out what c is, and we'll look at that a little bit later. So the general rule for integrating exponentials is it's one, we leave e to the kx the same, and we do 1 divided by the diff of the power. So it becomes 1 on k e to the kx plus c. So let me go through a couple of examples. E to the negative 3x plus 2 dx. If I do the diff of this bit up the top here, which is the diff of that becomes negative 3. So then I do 1 on negative 3, but I don't change the e to the power of, and so I just get 1 on 3, negative 3, e to the negative 3x plus 2 plus c. If I've got this one here, I've got two different functions added together. I get the diff, I do them separately, so I get the diff of this one here, which is a half, and so 1 divided by a half ends up being 2. And then the diff of this one here is negative 1, so I actually get minus e to the minus x plus c. Okay. If I've got something like this, again, I can't use the quotient rule because there is no such thing for integration. So what I need to do is I actually need to break these up separately and make them e to the 2x, because e to the 5x divided by e to the 3x is e to the 2x, and negative e to the x divided by e to the 3x becomes negative e negative 2x, the dx. So now I can integrate these two things separately. So the diff of this 2x is just 1 on, or is just 2, and then I do 1 on 2, and the diff of this one here is negative 2, so I make this, it's negative, and a negative will make a positive, so I get plus a half e to the negative 2x, and then I put my plus c at the end. Okay, and then I get this question here, which looks a little bit tricky, but it's not too bad. Again, there's no product rule for anti-diff, but if I expand this function here, I'm going to get e to the 2x minus 4, and because I've got a plus and a minus, I don't have a middle term, and now I can just do the integration of this one as I would have done any of the other ones. So the integration of that becomes 1 on 2 e to the 2x, and then minus 4x because I have to raise this to the power of x as well. So I get that one there. So the general rule for these kinds of things, it's not too difficult. It's I leave the exponential the same, but then at the front I do 1 on k, or 1 on the diff of whatever's in the power. Okay, and always remember the plus c. So Thanks for watching. In the next video, I think, what are we going to do? The next video, we might do the diffing of sine and cos graphs. So the anti-diffing of sine and cos graphs. So that should be good. I'll catch you then. Thanks.